All right, Advanced Math A, here we go. We got lesson 7.2.1, studying quadrilaterals on a coordinate grid or a coordinate plane. So 7-84, we're going to draw some line segments and ignore what I did in pink here because I wasn't reading my instructions at first. So we're going to draw the line segments, segment AB and segment CD. So AB goes from 0,8 to 9,2. And then segment CD, so that's the purple one there. And then CD goes from 1,3 up to 9,15, and that's the dark blue one. We're going to ignore the pink because I got carried away with myself and just really wanted to make this into a quadrilateral. Anyways, moving on. All right, so the first thing we're going to do is calculate the lengths of the segments. Okay, so the lengths of the segments, let's start with AB. So if I want to do the length of AB, what we can do is the Pythagorean theorem. So we're going to go from A to B. So that means we're going to go down. We're going to make this into a right triangle. So it looks like we're going to go down a total of 1, 2, 3, 4, 5, 6. So we're going to go down 6. And then we're going to go this direction for a total of 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes. All right, so the purple line, the segment AB, is going to be the hypotenuse. So that's a distance of 6. This is a distance of 9. So we can just say that AB is going to be equal to A squared plus B squared equals C squared. Now let's look at a shortcut that we can do here. Since we're going to do 6 squared and 9 squared, we're going to do 6 squared plus 9 squared equals C squared. Well, what we're going to do to find out what this hypotenuse C is we're going to take the square root of both sides. So C is going to be our segment there, is going to be the square root of 6 squared plus 9 squared. So we're just going to write it like that instead of writing out the whole thing. So AB is going to be equal to the square root of 6 squared plus 9 squared. So this would be 36 plus 81. And combine those two terms, 36 and 81 together, and I'd get like 117, I think. I think I'm correct. Now 117 is not a perfect square, so this one is going to give you a irrational answer, a number that just goes forever. So if we do our calculators here and we do the square root of 117, it tells you 3 root 13. If you've got this kind of calculator, it will like reduce the radical for you. But if you want to get it as a decimal answer, you're going to click this button down here. And that comes out to about 10.8 is what we're going to call it. Remember, these numbers, if they're radicals, go on forever. So it's impossible to actually write down the number. So we're just going to round it to 10.8, and that's its distance. So we're going to say it's approximately 10.8. All right, so that's the distance from A to B. It's about 10.8 units. All right, now let's do C to D. All right, so the distance of C to D. Now again, we're going to kind of make a right triangle out of this, where CD is my hypotenuse. So let's count out these distances. This is 1, 2, 3, 4, 5, 6, 7, 8. That's a distance of 8 there. And then it's going to go up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So then it goes up 12. So here I've got a right triangle because this is a right angle right here, right? So it's A squared plus B squared equals C squared. And just like the last one, we're going to just kind of do a shortcut there and take 8 squared plus 12 squared. So this would be 64 plus 144. And that should come out to 208, I think. 64 plus 144, 208. So I get it's going to be the square root of 208. 208 is not a perfect square. So then we're going to take out our calculator and we're going to go, okay, what is the square root of 208? It reduced it for me, but no, I want a decimal answer. So calculator, give me the decimal answer right here. And it comes out to 14.4. So this is approximately 14.4. Sweet. All right, so to find the lengths of the segments, we're going to make right triangles. And then we're going to do a squared plus b squared equals c squared. And then our shortcut for it is we're going to just do the square root of a squared and b squared added together. All right, next, write the equation of AB and CD. All right, so AB and CD, I need to write their equations. Now, AB, we already know what its y-intercept is going to be, and we can find the slope. So I know that the slope of AB, well, let's do it in blue since we did it in blue before. So AB, we know that the y-intercept, well, let's see, the slope is going to be down 6 and then to the right 9. So there's a slope triangle right there for AB. So that's going to be negative 6 over 9, which is going to reduce 3 goes into both of those to negative 2/3. The y-intercept, we already know. The y-intercept's right here. It's at 8. So this one's easy. All we have to do is say it's y equals negative 2/3 x plus 8. All right, for this one, not as easy for CD because they did not give me a good y-intercept here, and it looks like it's going to cross at probably a fraction. So here's what we're going to do for CD. We know that the slope, we've already counted it out here. It's going 12 over 8 because the rise is 12 and the run is 8. So our slope for this one is going to be 12 over 8, which reduces, 4 goes into both of those to 3/2. So there's our slope. And now we're going to, we don't have a y-intercept, so we need to find our y-intercept. So remember how we did that? We used y equals mx plus b. So we used the equation y equals mx plus b. And we used one of the points for the y and the x. So let's use the smaller numbers. Let's go ahead and use this point. So y is 3, so I'm going to write 3 equals m is 3 over 2, x is 1, plus b. And I'm looking for b because I have my m, I need my b. All right, so this is 3 equals negative, or 3/2. I'm going to subtract it in a second. That's why I said negative. So I'm going to subtract 3/2. So remember, this is 3 and this is 1.5. So if I take 3 minus 1.5, I get 1.5. So I'm subtracting 3/2 from both sides, and I get b is equal to 3/2 or 1.5. Because I'm going to subtract 1.5 from both sides, so 3 minus 1.5 is 1.5. So I don't know how you want to do it. I usually do fractions because I like them. So my equation for this other one is y equals 3/2 x plus 3/2. All right, so I got my two equations. What's the relationship between the lines? Well, let's look at these slopes. This slope is 3 over 2. This is negative 2 over 3. Those are opposite reciprocal slopes. So opposite reciprocal slopes means that they are perpendicular to each other. So opposite reciprocal means that this one's negative, but this one's positive. That's opposite. Reciprocal means that the numerator and the denominator have switched places. So this was 2 over 3, this is 3 over 2. So they have to be opposite, one positive, one negative. Reciprocal, where the numerator and denominator have switched places. All right, use algebra to find where the lines intersect. So since I have these both right here in slope-intercept form, I can use the equal values method for this. So I can just say, okay, since both of these are y, I can set these two equal to each other. So I'll write negative 2/3 x plus 8 equals 3/2 x plus 3/2. I don't like all these fractions on mine. So I'm going to multiply by, let's see, the common denominator is 6. So I'm going to multiply everything by 6. And then that will get rid of my fractions. So 6 times 2/3, 3 goes in 6 twice. 2 times negative 2 is negative 4x. 6 times 8 is 48. 6 times 3/2, 2 goes into 6 3 times. 3 times 3 is 9, so we get 9x right there. And then 2 goes into 6 3 times. 3 times 3 is 9 again. All right, we don't have any fractions. That's much better. Let's add 4x to both sides. That would give us 13x plus 9. Let's subtract 9 from both sides. If I subtract 9 from both sides, I get 39 over here. Divide by 13, and I get x is equal to 3. Okay, so I got x is equal to 3. Now I need to find out what my y value is going to be. So I'm going to plug it into this one up here. So I'm going to get y equals negative 2/3, and then we said x is 3, and then plus 8. So I get y equals 3 goes into 3, they reduce each other, so that's just negative 2 plus 8. So y must be 6. So it looks like I got an answer of 3, 6. Let's go to our graph and see if that is correct. So 3, 6 is at 1, 2, 3, 1, 2, 3, 4, 5, 6. Yes, that's exactly where they're crossing right here. 3, 6. Boom, did it. All right, next thing we're going to do, we're going to look at this resource page that we have. There's 2 pages to this. It has a whole bunch of different shapes. And we're going to state what the special properties are for the shape. So the first one is a regular hexagon. So a hexagon has 6 sides. Regular means that all sides are congruent. So this side, this side, this side, this side, this side, this side, all those sides are congruent. Regular also means that all the angles are congruent. So this angle, and this angle, and this angle, and this angle, and this one, all of those 6 angles are congruent to each other. All right, next one, a kite. In a kite, we've got 2 pairs of adjacent congruent angles. Okay, so 2 pairs of adjacent congruent, did I say angles? I meant sides. Congruent sides. So this side is congruent to this side. Those are adjacent. Adjacent means next to. And then this side would be congruent to that side. So that is the kite. We actually have a pair of angles. 1 pair of the opposite angles are congruent. And the angles that are congruent are always the angles that are between the different sides. These two angles are not congruent, but these two always will be. A rectangle. In a rectangle, all the angles, different color. There you go. All angles are 90 degrees. Opposite sides are congruent. And opposite sides are parallel. So all these angles are 90. They're all congruent to each other. The opposite sides are congruent to each other. And finally, the opposite sides are parallel. Remember, we show parallel by the little arrows. So this side is parallel to this side. And then this side here is parallel to this side over here. Using our arrows, we're showing parallel. Scalene triangle. All sides are different. What color should I pick? Pink. And all angles are different. So that means this side is different from this side, which is different from this side. And this angle here is different from this angle here, and that's different from this angle here. Nothing is the same in a scalene triangle. All right, a quarter of the way through with all of our shapes. There's lots of them. Next one, a trapezoid. A trapezoid is when we have one pair of parallel sides. One pair of parallel sides. So this side here is parallel to this side here. And that's about all we can say about that. Okay, next up, we can also look at these two angles and go, oh, those are same side interior angles, so these two angles would be supplementary to each other. But I think we'll skip that for this one. Okay, equilateral triangle. An equilateral triangle is regular. And just like we did, oops, I was supposed to do a different color, wasn't I? Just like I said regular on the other one, let me do it in dark blue, because these things make me happy. All right, so a equilateral triangle is regular, just like a regular hexagon, where all the sides are congruent and all the angles are congruent. So we're going to say all sides are congruent and all angles congruent. So this side, and this side are all the same, which also means that these angles are the same. A square is regular. It's a regular quadrilateral. All sides are congruent. Got to change colors, dang it. And all angles are congruent. So all four of these sides are the same, and all of these angles are the same, which means they have to be 90 degrees. So all angles are congruent, and they're all right angles. They're all 90 degrees. Okay, an isosceles right triangle. Well, first thing it says is that it's a right triangle, so that means it has a right angle. So one right angle. So let's put that right angle right there. And it's isosceles. So it has two congruent sides. So let's say this side is going to be congruent to this one. Now, since it's isosceles and right, that means that these other two angles are also congruent. So it has two congruent angles. And since it's isosceles, since it's a right triangle, you could also use the Pythagorean theorem to find out the side lengths if you wanted to. All right, halfway there. Next, a circle. Circle has no sides. And a circle, what else can we say about it? It's equidistant from the center. So the side of a circle is equidistant from the center. It's the same distance. So anytime that we connect the center with a side, that is called a radius, and they're all the same. So that's an R, that's an R, that's an R. Yeah, let's stick with that. That's a special property, is that the outside is equidistant from the center. I'm happy with that. Let's move on. All right, next one, a rhombus. A rhombus is, oh, I forgot. Did I forget? Yeah, I did, huh? I forgot to say that in a regular, in a square, a regular quadrilateral, that opposite sides are parallel. That was parallel, and this one is also parallel. That's parallel to that. I knew I was forgetting something. So here we were supposed to say that opposite sides are parallel. Are parallel. And also, since we're saying that these are 90-degree angles, that means that the consecutive sides or the adjacent sides, they're going to be perpendicular to each other. So that's important too, I guess. All right, let's jump back to here. A rhombus. A rhombus is a quadrilateral where all the sides are the same. So you might be thinking to yourself, well, doesn't that mean it's a square? Nope, it doesn't mean it's a square. It just means all the sides are the same, but not all the angles are the same in this one. So all the sides are congruent. Now the opposite sides are parallel. So this side over here is parallel to this side over here, and then this side here is parallel to this side over there. Now we do know something about the angles. The opposite angles are congruent. So this angle here is the same thing as this angle over there, and this angle here is the same thing as this angle over here. All right, a quadrilateral. That just means it has four sides. Nothing special about it other than it having four sides. So technically, a rhombus is a quadrilateral because it has four sides. Isosceles triangle has two congruent sides. So maybe this side here and this side here. Those would be congruent, but it also has two congruent angles. And we call these the base angles. So this angle here and this angle here. So they're the two angles that are opposite of the sides that are congruent. All right, a scalene right triangle. So in a scalene right triangle, all the sides are different. And one angle is 90 degrees, which means two of the sides are perpendicular to each other. All right, next one, we've got a isosceles trapezoid. Okay, so since it's a trapezoid, trapezoid means that one pair of sides is parallel. So one pair of parallel sides. And then, since it's isosceles, we call these over here legs. So this leg here is congruent to this leg here. So it has one pair, or let's just say the legs are congruent. And then it also has congruent base angles. Now there's two bases. There's a base on the bottom and there's a base on the top. So we're going to say congruent base angles. So this angle down here is the same as this angle down there. So that's one of our bases. Our second base is up here. And these two angles end up being congruent to each other up there. Parallelogram. Opposite sides are parallel. That's why it's called a parallelogram. So opposite are parallel. So this side here is parallel to this side here, and this side here is parallel to this side here. Okay, we also know that opposite sides are congruent. So this side here is congruent to this side, and this side here is congruent to this side, and the opposite angles are congruent. So let's do this one here and this one here are the same, and then that would mean that this angle here and this angle here are the same. That's a lot. All right, last one. A regular pentagon. Remember, regular means all the sides are congruent and all the angles are congruent. So all sides are congruent and all angles are congruent. So this side, this side, this side, this side, this side, those five sides are congruent. And this angle, this angle, this angle, this angle, and this angle, those would all be congruent. All right, so this is kind of a nice thing to keep around to help you remember the different properties for all of our basic shapes. Let's get back to our notes and finish them up. All right, last part. Shayla drew the quadrilateral over here. What is the perimeter of quadrilateral Shay? S-H-A-Y. So here's our quadrilateral. We want to know what the perimeter is. Well, in order to know the perimeter, we have to know what each side length is. So let's write down each of the sides. Let's start over here. S to H. So SH, since that's a vertical side, I can just count it out. 1, 2, 3, 4, 5. So SH equals 5. So that's the length from S to H. Now, if we want to do from H to A, we would have to do a right triangle here because this is not vertical. So here I've got 4, and over here I've got 3. So it would be, ooh, I haven't been moving enough. There we go. So we're going to do the square root of 3 squared plus 4 squared. So this is the square root of 9 plus 16. 9 plus 16 is 25. Oh, so that one's 5 too. All right, so from H to A, we got a distance of 5. Let's do from A to Y. So from A to Y, since it's diagonal right here, it's not vertical, it's not horizontal. This is a distance of 3 here and 4 here. So I got a right triangle, so I can do 3 squared plus 4 squared equals this side squared. So A to Y would be equal to the square root of 3 squared plus 4 squared. Well, it's the same thing as this one, so we know that this is going to be the square root of 25, which is going to be 5. So all of those sides so far are 5. This one's 5, this one's 5, this one's 5. All right, let's find out for SY what that distance is. So from S to Y, I don't think this one's going to be 5. It goes down 1, 2, 3, 4, so that's a distance of 4. And this way goes 1, 2, 3, 4, 5, 6, 7, so a distance of 7. So we're going to do the square root of 4 squared plus 7 squared. So this is 16 plus 49, which is 65. That's not a perfect square. It's really close to 8. I bet it's going to be like 8.1 when we plug it in there. Let's see. So the square root of 65, yep, about 8.1 if we round it out. So this is approximately 8.1. So if we want the perimeter, we would add up these 5 sides. Okay, let's add those together. If we do 5 plus 5 plus 5 plus 8.1, so 15 plus 8.1 would be 23.1. There's my perimeter. This is supposed to say thinks instead of things. Close enough. Okay. All right, Shayla thinks her quadrilateral is a trapezoid. Is she correct? Ooh, trapezoid. Where was that one? Okay, trapezoid. She thinks it's one of these. Okay, so we have to know if it is that we've got one pair of parallel sides. So let's go ahead and look at the slopes of all her sides. So her sides are SH, and the slope of this side here is vertical, so that's an undefined slope. Let's look at HA. That slope goes up 3 and over 4, so that's 3 over 4 for the slope. Let's look at the slope for AY. AY goes down 4 and over 3, so AY equals down 4 over 3. And the last one will be over here. This one goes up 4 and over 7. So SY goes up 4 over 7, so 4/7. All right, so if it's a trapezoid, it has to have one pair of parallel sides. So this side here, AH, is 3/4. And is it parallel to this side? No, that's 4/7. It's close, but they're not the same. In order for us to have parallel sides, they'd have to have the same exact slope. So we're going to have to say that no, she is not right. So no, none of the sides are parallel. So to prove that they're parallel, they have to have the same slope. None of these slopes are the same, so we can't have any parallel sides. Does Shayla's quadrilateral match any of the ones from our list? No, it doesn't match any of the ones from our list. So all we can say about it is that it's just a quadrilateral. Okay, just because it's not a named quadrilateral, it does have it has some interesting characteristics about it that we could add to this. You're looking at the sides of this quadrilateral, 3 of the sides were congruent. So that would be kind of interesting, even though none of the quadrilaterals have 3 sides congruent. It's something. So it does have the properties of 3 congruent sides. Any other properties? Well, there is one more property that's pretty interesting. We've got 3/4 and negative 3/4 for these 2 sides. So we have one 90-degree angle. Because we have opposite reciprocal slopes, so we can say that HA is perpendicular to AY. Other than that, it doesn't really have any other interesting properties, but it's a quadrilateral with 3 congruent sides and one 90-degree angle. There you go. That's all I got for you today. Math hard. See you later. Bye-bye.